All right, now we're on to Unit 5. So this table is differentiable. In which of the following intervals must there be a number c such that f prime of c equals 1? So obviously if they tell us f prime of c, they really want us to use mean value theorem. So we got to figure out where, on what interval, will we have a slope equal to 1. So I'm just going to try out all these points and see which one gives me a slope of 1. So for A, these that they give us are x values. So if I plug those in, I have -1, -1, over 2 minus 0, which gives me -2 over 2, and that's -1. So that slope won't work. B is from 2 to 4. So for B, I'll have 5 minus -1 over 4 minus 2, which is 6 over 2, which is 3. So it's not B. C from 4 to 6, so it's 7 minus 5 over 6 minus 4, which is 2 divided by 2, or 1. So C. Um, 82, let there be a function. What is the value C on 0 to 3 that satisfies the mean value theorem? So basically, they give us this interval, and we're trying to figure out what slope value we need. So the first thing I'm going to do is find f of 3 and f of 0. And I do that just by plugging it into the original equation. So 3 squared plus 2 times 3 is 9 plus 6, which is 15. And then 0, we get 0 squared plus 2 times 0 is 0. So I put this into the slope formula, f of 3 minus f of 0 over 3 minus 0. I end up with 15 minus 0 over 3 minus 0. Sorry. Which would be 15 over 3, which would equal to 5. Now, it wants us to figure out where the derivative is going to equal to that. So I need to find f prime of x equal to, we know that's 2x plus 2. So I need to figure out where does this equal this. So I just set up a little equation, 2x plus 2 equals 5. Subtract 2, we get 2x equals 3. Divide by 2, we can see x equals 3 halves. And we know 3 halves equals 1.5. So that's going to be our answer for 82. Okay, 83 is a continuous, always increasing function. Which of the following is false? So, based on EVT, or extreme value theorem, we know anytime we have a continuous function, it has to have both a max and a min. So obviously it's going to attain a max, a min, and both. So the one that's false is D, that says it will have neither a max or a min. That is not true based on extreme value theorem. Okay, here we have the graph of f prime, and it wants to know where f is increasing. So I'm going to make my little chart. So if I want where f is increasing, I need where f prime is positive. And f prime is going to be positive from 0 to 4, and then 7 to 9. So D. Okay, they give us f of x. They want to know where f of x is decreasing. So this one's going to be not a graph one. We just need to find the critical points and make another chart. So let's start by finding the derivative. And its derivative is going to be e sine x. Because of chain rule, we multiply that by cosine x. And we want this to be equal to 0. Lucky for us, e sine x is never going to be 0. However, cosine x is. We know that happens at x equals pi over 2 and 3 pi over 2. That's the only time cosine equals 0. So now I can put it on my number line, pi over 2, 3 pi over 2. And then I'll just plug in values. So let's say I plug in something less than pi over 2. So I can plug in a 0 here. So we'll have e to the power of sine of 0. E to the power of 0 is 1. And then cosine of 0, we know is a positive 1. So that's going to be positive. In between pi over 2 and 3 pi over 2, we can take pi, and we know cosine of pi is negative, so that's negative. And then greater than 3 pi over 2, we can take 2 pi. It's going to be the same as 0, so it'll be positive again. So it's increasing, decreasing, increasing. So the only time it's decreasing is from pi over 2 to 3 pi over 2, or a. Okay, 86 wants to know which of the following is true. So let's look at f of 2. F prime of 2. And f double prime of 2. So f of 2, we can see the y value there is going to be equal to 0. F prime of 2 means the slope there is going to be decreasing, so it's going to be a negative. And then our second derivative of 2 depends on concavity. This one looks like it's concave up, so the second derivative has to be positive. So if we put these in order, it should be f prime of 2. F of 2 is in the middle since it's 0. Then f double prime of 2, which makes our answer C. Okay, we want to know where f of x has a relative maximum. This is f prime. So let's think about our chart. We want a relative maximum. Here's f. That tells us we want f prime to change from positive to negative. So the only times it changes from positive to negative, it's going to be right here at -4, and that's it. That's why our answer is A, -4. '88, so we need to find our critical points. And I know my derivative of natural log is 1 over everything we had, so x cubed plus 5x squared plus 5. Then that gets multiplied by its derivative, so times 3x squared plus 10x because of chain rule. So then I have 0 equal to 3x squared plus 10x over x cubed plus 5x squared plus 5. Now, if I want to set this equal to 0, only a couple places matter. Because this bottom isn't going to matter, we could multiply it and it wouldn't affect our answer. So really, we need to figure out where does 3x squared plus 10x equal 0. I'll factor out an x to give me 3x plus 10. So my critical points are x equals 0, and x equals negative 10/3. So I'll put both of those on my line. So negative 10/3, 0. And then I'm just going to plug in values to see where I'd have a positive and a negative. So if I plug in something less than negative 10/3, if you do the math, you're going to end up with a positive number. If I plug in, let's say, negative 1, you end up with a negative number. And let's say I plugged in a positive 1, you'd end up with a positive number. So if I look, the only place that I'm going to have a relative minimum is right here, where it changes from negative to positive, or when x equals 0. All right, so we have a relative minimum at x equals a. And we want to know which of the following must be true. So in order for us to have a relative minimum at all, let's look. We have our critical point. Relative minimum is when it changes from decreasing to increasing, which means f prime is going to change from negative to positive. So B is not true because it's the wrong way. F prime changing from decreasing to increasing, we know it should be negative to positive. Concave down to concave up, that's not even relevant. We know it has to be A because if f prime does not equal 0, it's not a critical point. And therefore, there can't be a relative minimum there if it's not a critical point. Okay, I need the absolute minimum. So the first thing we need to do is find our critical point still. So if I take the derivative, I end up with 4x squared minus 16x plus 15. And then I'm going to factor that. And that factors to 2x minus 5, 2x minus 3. So my two critical points are going to end up as 5/2 and 3/2. And because this is all about absolute minimum, I have to make this chart with my endpoints, so 1 and 3. And then I'll put 3/2 and 5/2. Now to find these values, I'm going to plug it back into the original equation. So if I plug in a 1 there, let's see. We have 4/3 minus 8 plus 15, which I believe is going to end up as 25/3. When you plug in 3/2, again, you can do this in your head. I believe it's going to be 9. Plug in 5/2, you get 25/3. Plug in 3, you get 9. So if I want the minimum value here, we have to figure out which one is smaller, 25/3 or 9. Well, we know 9 is the same as 27/3. So 25/3 is smaller. That means it is our absolute minimum value. They would probably give you a calculator on those fractions. Maybe not, but hopefully. 91 is an absolute maximum, so it's going to be kind of the same process. We start with the derivative. Remember, this is 32x to the 1/2. So when I multiply that, I get 16. And then that becomes x to the negative 1/2, which is the same thing as over square root of x minus 2x We want that equal to 0. So I'll add 2x to both sides. Multiply by a square root of x, which leaves me with 2x to the 3/2. Then I can go ahead and divide by 2. So x to the 3/2 equals 8. And then to get rid of that, I'm going to multiply this by 2/3, or exponent 2/3, which leaves me with the cube root of x, or 8 squared. So when I do this, I'm going to do the cube root first, so I get 2 squared equals 4. So my critical value here is going to be 4. Once again, I'll make this chart. And I put the endpoints, so 0, 4 for my critical point, and 9. Then I plug these back into the original equation. So I have 32 times square root of 0 is 0, minus 0 is 0. Then I have 32 times square root of 4, so 32 times 2, which is 64, minus 16, should be 48. And then I plug in a 9. I have 32 times 3, minus 81, should end up being 15. So my absolute maximum here is going to be 48. Okay, here I need to figure out where it's concave up, so this has to do with the second derivative. So there's our first derivative. Our second derivative is 6x minus 4. Set that equal to 0 to find our possible points of inflection, which gives me 4/6, or 2/3. And then I'll just put them on my interval. And remember, you're going to plug this back into the second derivative since we're looking for concavity. So if I plug in a number less than 2/3, let's say I plug in 0, I end up with a negative number. If I plug in a number bigger than 2/3, so 1, I'm going to end up with a positive number. So anytime your second derivative is negative, concave down. Second derivative is positive, concave up. So concave down is going to be from negative infinity to 2/3. K93 wants to know where on this graph f of x is concave down. So let's make our chart. Concave down, we should know f prime is decreasing, f double prime is negative. But this is a graph of f prime, so I'm just looking for where is f prime decreasing. So if we look, it's going to be from -6 to 4. And then -4 to -2. So really from -6 to -2. And then again from 4 to 6. So the answer will be D. '94, we have to find the point of inflection. So again, second derivative. So I get 6x minus 12, set that equal to 0. And you should get x equals 2. Put that on our number line. Plug it back into our second derivative. So if I plugged in a 1 there, I'd end up getting a negative number. Plug in, let's say, 3. I get a positive number. So it's concave down to concave up. In order for it to be a point of inflection, it does have to change concavity. So in this case, we're good. It would be x equals 2. Right? Differentiable function, f prime of a equals 0. Which of the following values of f double prime guarantees that x of a is a relative maximum? So if we think about maximum, second derivative test is all about concavity. So looking here, we know that one of these points is a. So if we see we want a relative maximum, that should tell us it has to be concave down. Because here would be a relative minimum. So if I want it to be concave down, let's think about what that tells me. So I know that means f is concave down, f prime is decreasing, but we don't care about that. F double prime has to be negative. So the only one of these that has a negative f double prime is a. That would guarantee it has a relative maximum because it would be concave down. Okay, 96. This tells us that y prime is negative. And y doubled prime is positive. Whoa. So when y prime is negative, that tells us that y is decreasing. And when y double prime is positive, that tells us that it's concave up. So that's what we're looking for. Decreasing, concave up. This one is increasing, concave down, so not a. Decreasing, and it looks like a cup, so it's concave up, B. This one's decreasing, but concave down, so no. Increasing, concave up. So no, the answer is B. Okay, here's our graph of f prime. They want us to map it to f. So looking at this is telling us all about our slopes. So it's going to have a negative slope until about right here. So negative slope, that matches. Positive slope for C. Negative slope looks good. Positive slope. So it's either A or B. And then it becomes a positive slope all the way back over to here. So positive slope all the way up. This one stays negative the whole time, so it can't be B. Our answer here is A. Uh, 98 is an optimization problem. We skipped that, so look it up yourself. Okay, this one tells us the curve at xy plus y squared equals 5x minus 11 has a vertical tangent. So basically, we need to figure out where it has an undefined slope. So the first thing we're going to do is find the slope. We have x's and y's together, so we need implicit. So it's going to be the first times the derivative of the second plus derivative of the first times the second plus 2y dy dx equals 5. Then I'm going to get all my dy dx's to one side, everything else to the other, and factor it out. And then divide by x plus 2y. So this tells me that dy dx has to equal 5 minus y over x plus 2y. And if I want a vertical tangent, I know the bottom has to equal 0. So x plus 2y has to equal 0. But I want the x value here. So what I'm going to do is I'm going to solve this for y. So y is going to equal negative x over 2. Now I'm going to plug this back into the original equation and try to solve for x. So I'm going to have x times negative x over 2 plus negative x over 2 squared equals 5x minus 11. So this is going to become negative x squared over 2. Then this is going to become plus x squared over 4 equals 5x minus 11. I'm going to multiply everything here by a 4 just to get rid of the fractions. So if I multiply everything by a 4, this is going to become negative 4x squared over 2. So basically negative 2x squared plus x squared equals 20x minus 44. Then I'll combine everything. So negative x squared equals 20x minus 44. Move that x squared over, so 0 equals x squared plus 20x minus 44. Then if I factor that, you should end up with x plus 22, x minus 2, which leaves you with x equals negative 22 and x equals positive 2. So C will be our answer. Okay, 100's pretty much the same thing, but this time we're looking for a horizontal tangent line. So I'll start with finding my derivative again. So 3x plus 2y dy dx equals 27. Get dy dx by itself. So dy dx equals 27 minus 3x over 2y. And then horizontal tangent means set the top equal to 0. So 27 minus 3x equals 0. Sorry, this should be 3x squared. So then I have 27 equals 3x squared, which makes 9 equal to x squared. Square root it. You should get positive 3 and negative 3. So our answer would be